All right, so today we're going to be doing experimental and theoretical probability. So what you did yesterday was actually very similar to theoretical. But we'll discover the definitions for both of those. So experimental is, let's see if I can get this smooth, is a ratio of the number of times event occurs to the total number of trials. So basically, experimental is what actually happened. So it means that you actually have results for your experiment. Theoretical is a probability of an event happening based on the possible outcomes. Basically, what should happen. And that's what we did yesterday. Theoretical is if, in theory, like if I give you a dice, 6 will appear 1/6 at a time. That's in theoretical. Now, if you actually rolled the dice and you got data, you got numbers to appear, that's experimental. So, first one is, what's the theoretical probability of spanning a section with stripes? Well, first off, find your total. There's 8 sections, and only one of them has stripes. So you have a probability of 1 out of 8. That's like what we did yesterday. So what's the theoretical probability of spinning a stars? Well, there's 2 stars. So it'd be 2 out of 8, which equals 1/4. And then what's the theoretical probability of not spinning a solid or a striped section? So I'm going to get rid of all my solids and stripes. So I have 3 sections left. So I'll be 3 out of 8. And that's theoretical, like what we just did yesterday. Now, let's say I actually did experimental. So this is experimental. Because what I did is I actually went and I spun the spinner and I got these results. I got 2 stripes, 3 white, 2 dots, and 3 stars. So I spun it a total of 10 times. So this is my experimental because I actually did it. So my experimental probability of getting stripes is now 2/10, which is 1/5. My experimental probability of white is 3/10. My dots is 2/10, which is 1/5. And then my stars is 3/10. So when you do an experimental probability, you use the total number of times you did the experiment. So it says, are there any results in which the theoretical and experimental probability are the same? No, but they're relatively close. Okay, it's okay for experimental and theoretical not to be the same, but they'll be in the same proximity. They're very close to each other. So relative frequency is the total number of successful attempts divided by the total number of trials. It can be used to make predictions. And we'll talk more about predictions on Friday. As the number of trials increase, the relative frequency of an event will approach the theoretical probability. So let's try it. The spinner is spun 50 times, and the results are shown in the table below. Complete the experiment. So it was spun 50 times, and the number 1 appeared 12 out of those 50 times. So it'd be 12 out of 50, which is 6/25. Next one would be 8 out of 50, which is 4/25. Next one would be 13 out of 50, which is simplified. This one would be 10 out of 50, which is 1/5. And then the next one would be 7 out of 50. So that was my experimental probability for spinning it 50 times. Well, now I did it 100 times. So my results are here. It'd be 20 out of 100, which is 1/5. This one would be 20 out of 100, which is 1/5. This one would be 24 out of 100, which you can simplify it down. And I'm going to confirm my answer, which is 6/25. This one would be 20 out of 100, which is 1/5. And then this would be 16 out of 100. My pen's just not working today. which is 4/25. So these are relatively close to each other. They're basically double the amount. And we'll talk more about that on Friday when we're talking about predictions. But we're going to compare this results to the theoretical. So before I even do that, it says, what did you notice as you spun the spinner 100 times? What patterns did you discover? Well, it says the theoretical and the probability of landing on each number is 1/5. And we'll talk about that in the next slide, or 20%. After 100 spins, the most of the experimental probabilities are or at close to 20% or 1/5. And we actually had 3 of them, which were really close to being probability of 1/5. So it says, what's the theoretical probability of spinning each of the numbers? So the probability of 1 is 1/5. All of these are 1/5. So it says, how does the relative frequency change when the spinner is spun 50 times versus 100 times? As the number of trials increase, the more the long-term relative frequency approaches the theoretical probability. So basically it's saying the more you do the experiment, the closer it should get to the theoretical. So suppose a spinner is spun 1,000 times, predict the relative frequency. Well, when I do that, 1,000 times is a lot. So I would predict probability of getting 1 should be 1/5. I should predict all of these should be about 1/5 because that's a long time to spin it. So these should get closer and closer together, and that's what they're trying to say. That's basically about all we're doing. Your homework is relatively the same, if not a little bit easier. But I do want to do a couple problems with you on your homework. So homework on number 1 says, what's the probability of getting a heart? And so you did this 30 times, and the heart appeared 9. So this would be 3 out of 10 times. This is experimental because you use your results to find the probability. Now, number 2 is asking, what's the theoretical probability of getting a heart? Well, to be able to do a theoretical probability of getting a heart on a standard deck of cards, you need to know some information about cards. So a card has 52 cards in it. A standard deck has 52 cards in it. 26 of them are black, 26 of them are red. That means half and half. Okay? There are 4 suits. Each suit has 13 cards in it. There are 13 spades, 13 hearts, 13 diamonds, and 13 clubs. Each suit goes from 2 to ace. So 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, king, queen, ace. Spades are black, hearts are red, diamonds are red, and clubs are black. So I'm trying to find the theoretical probability of getting hearts. Well, there's 13 hearts out of 52. Okay? Well, also hearts is 1/4 of the deck. So it means you have a 1/4 chance of getting a heart. And that'll help you. And we'll do card decks more and more, but we just need to get used to them. Okay, so I would advise you to write this down on your homework page. Thank you, guys.